Okay, this is going back a little bit, but how do you make the QQ plots again? Oh, found it. Kidding. Take it back.
You deal with the residuals, right?
Yep. I should just excited to pull up the data. Wait, did you ask? We're doing the residuals, right? That's what you said.
Yeah.
And that's under the Excel one. Okay. Or I guess you could do it in SPS too, huh? Analyze, regression, linear. Okay, so residual, is that just essentially R?
Sorry, what was that?
So I did the residuals like it says in the sheet, but I don't understand what. So I have all the data pulled up and the residual statistics, but I don't understand like what I would be looking for. I have a residual of negative 34.03, but I guess I don't know how to read the data.
So which graph are you trying to make?
Well, I was just doing the residuals for the constant variance, the third assumption.
Mm-hmm.
And so I guess I was doing the residual plots, and I didn't come up with the plots, so maybe I didn't. Oh, I just come up with the residuals. Okay. Okay. Now I did it. So when we have residuals, we just don't want them to form any shape, right?
Yeah, this is no megaphone shape for the. I guess we're checking for the scatter plot.
Review. So there's no weird numbers for X. And observations are independent. Okay. So it's under all the assumptions, right?
Yeah, I believe so.
Ooh.
I was looking at the answer key, the graph that I made for the constant variance, the residual plot. It doesn't seem to match the plot that we.
Okay, let me pull up the answer sheet. But oh, oh yeah, mine looks different than well. Let me really look at it. Hold on.
I chose the x-axis as the fifth one, but I don't know what's going on with things.
You know what? I think mine, like, it's not set up like theirs, but I think if I put it in that format, it would look the exact same. Yeah, I'll show you what I have. I have like so many windows and different windows. I can't even see my head. Yeah. Okay. Can you see this? Is yours
Okay.
like this? What did you say?
That looks like what I have.
Okay, so looking at their graph, they just moved this X up here. So it cuts between there. When I do that, I realized, okay, well, they had a few down here and a few ones bigger up here. And our X values are the exact same, negative 40, negative 20, 0, 20, and 40. So I think it's just because they shrunk their graph and then they put bigger points on it, it makes it look different. But when you look at the numbers, they are closer.
Mm-hmm. Alright, sounds good.
That makes sense.
So, all the assumptions on that. So, I guess we'll test it. So, the null is.
Are you just going to do the thing in the Excel spreadsheet?
Huh?
Are you just going to do the testing in the Excel spreadsheet?
I don't know, is it easier? I haven't looked at the sheet with you.
Yeah, I just pulled it up and I thought, I didn't see how to do it in SPSS, but this seems really easy.
I'll do that too. Oh, linear regression. Here it is. Yeah.
Yeah, I feel like I just put in the data, I just copied and pasted it over from Excel, the other Excel sheet, and it did it pretty much everything, except for the plots. Oh wait, I didn't zoom out enough. Wow, it literally does everything but the QQ plots. Okay, so the null, sorry, I know you probably are close in, but the null is not equal to 0, and then the other one is b beta 0 equals, wait, the first one is equal to 0, the second one is not equal to 0, right?
Yeah.
Okay, then, okay, so the test statistic I have as 22.675, right?
Let's see. Yeah. Correct. Based on the p-value, do you reject or fail to reject null? Rejecting null.
So you're gonna be lazy. And then have to do a class. That means you're drinking fixed tacos.
Sorry, did you sorry, he started talking to me and I got totally distracted. Did you come up with that same test statistic?
Yeah.
I'm a little behind. Okay, and then the p-value, you just follow the one right next to it, right?
Mm-hmm. Yeah, I think so. And
5.08
zero.
to the negative 13, which is essential to notice. And then, got it. Right. And there is a linear relationship. Okay, so that's something I should remember too, is that in this one, when you reject it, you state that you're just trying to state whether or not there is a linear relationship between the data. Oh, interesting. On the answer sheet, it shows that SBS gives a different answer than Excel.
Really?
You have it. You have it for. Did you already eat?
Oh, and then when you
Okay.
do,
Perfect. What?
so then we need to copy some info.
Yeah, I think it's just on the Excel sheet.
Mm-hmm. Okay, yeah. 6.704.
Hopefully they just have us do like one test for the quiz.
Yeah.
Alrighty, should we call the group meeting? I mean, quiz.
Mm-hmm. think that's everything you do for the preparation assignment, right?
What?
Well, I guess we're supposed to state our conclusion. Sufficient
Oh.
evidence to conclude that.
So I peeked over the answer sheet because I wanted to see how they word it, and that was what I was saying, that it states that we have sufficient evidence to suggest that there is a linear relationship between the head and body length. And so, just in my head, I noticed that when we do these tests, the inferential data, you're just stating whether or not there is a linear relationship. That's all you're gathering from the test. Okay. Tell me when do you have the test open yet?
I got there, and I can't find the start button. It's starting to glitch out a little bit.
Oh, really?
I'll have that up in a minute.
Okay.
Okay, I have it up.
Okay. So number 3, essentially, what is the null of the alternative? And I said b equals 1. I mean, b equals 0, and then the alternative is that it doesn't equal 0.
Yeah.
So what is the residual? And let's say that. Yeah. What do you? Sorry. Go ahead.
I said a residual. And the observed value y and the value predicted by the regression y. What's left over after doing the simple regression? I think it's number 2. What is the is the difference between the observed value y and the value predicted by y, right?
That's what I think too. I agree with that.
What's that?
I said I agree with that. That's I think that is good. For the next one.
Flattery of the individual supports using the regression way. See a pattern in residuals. The residuals are all positive. You see a megaphone shape in residuals. Is that one, you know?
So I said it's that it's normally, and I'm not sure, but that they look normally distributed with 0 mean.
Oh.
What was your first thought?
It could be that one. Well, I guess if it's QQ plot it's talking about, it's kind of vague on what plot, but if it's QQ plot,
Well,
then I can.
no, it says a plot of the residuals. So It should be that plot, you know, the one that you just did, and we pulled up and we saw that the mean was 0, and then they had, like, it's the one that we just pulled up and I showed you on my computer. The answer sheet had the mean at 0. And they just want them all equally. Okay, here it says, if a linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter.
Oh, okay.
So we do not want a pattern.
Okay, so we want you see a pattern in residuals? Or?
No, so it's not the first one you see a pattern in residuals, because that is saying that if you do see a pattern, that's an issue. All the residuals are positive. That's not true because the one on the on the part 2 was negative. There was some negative residuals. You see a megaphone shaped in the residual, and we don't want that. So I just think by process of elimination, another way of putting it is the residuals look normal distributed about a 0 mean.
Yeah.
Compute the residuals from the math self-efficiency data using software. We use the confidence data as the explanatory variable and the score data as a response variable. Okay, confidence as X. Are you taking any other classes other than this, Colby?
I'm taking like English 201, I think it is.
Oh, okay. You read it so slow sometimes.
Okay. What statement best describes the residuals?
I'm so sorry, I'm still pulling the math self-efficiency up. Oh, we have another thunderstorm over here. It's so loud. So what is it that would do us, sorry, just because I'm opening up another screen. What one is the confidence score that is the independent or the confidence that's the independent and the score that's the dependent?
Sorry, what was that?
So confidence is independent and score is dependent?
Yeah, confidence is independent and score is dependent.
Yay, I made the QQ plot. Super slow, but it's. So, are we going to go for normal? Right?
Oh, did we skip number 6?
Oh, no. I just thought that was number 6. Okay, compute the residuals using this software. Okay. Okay. Let me go back. Read here. Oh, it's so much easier just in analyze.
Confidence score is dependent. Save instead of details. Now, analyze. Group plots. And fairly normal. Well,
Just scroll down. Just scroll down.
it's pretty much normal. Well, not normal, but
Oh,
it's pretty.
okay, sorry. Go on. Go ahead. Pretty normal.
It seems pretty linear. I mean, like a linear pattern.
Are they not supposed to be good though? I thought we don't want.
Uh, I think you want it. You want a pattern for the QQ plot, but you don't want a pattern for the actual scatter plot of like residuals to the explanatory variable.
Yeah. So I'm still on the residual one. Is that what you're on, or were you saying the patterns in the QQ plot?
I was looking at. Well, yeah, it looks fairly normal. So for number 7 anyway. I was just looking at number 6. What was linear pattern?
Okay, so for the QQ plot, I got that it was linear too, and then I'm still pulling up the residual right now. So cross your fingers. Oh, I did do it right. Woohoo! Okay, yeah, there's definitely not a real pattern there in the residual. So they're between like 20 something and 40, right? So for number 6, did you get A, that they're between negative 40 and 20?
Okay.
Or I guess, what did you get for 6 and 7?
Let's see, is it? 5. Yeah, and that is true.
I didn't do a QQ plot though of the residuals and X. I did a QQ plot of Y and X. Are we supposed to?
Do a QQ plot for the residuals. Guys,
For Y and X? Yeah, I didn't do them for the residuals. I just did it for Y and X. Is there a difference?
I think there can be anyway.
I guess. Did you do the QQ plot for the residual?
Mm-hmm.
And it looks normal then?
Yeah, I'll show you.
Okay. Oh yeah, that's quite normal.
At the ends, it kind
Awesome.
of goes a little bit, but it's fairly normal.
That's awesome. Okay, so so use software to create a scatter plot for this. So I did do the QQ plot for X and Y, and I feel like it's really linear. Do you want to see mine?
Okay.
Actually, I take it back. I think I deleted it. Hold on. For some reason, my SPSS is running super slow. Give me just 1 second and pull it back. Let's see here. Okay, I did have it. Here it is again. Oh, come on, little computer. Okay, so let me do the screen share with you. Sorry that took so long. Okay, so here's the QQ plot that I got. It will scroll down in a second. There we go. So I feel like it is pretty normal. What do you think?
Yeah, it does.
Okay, so turn the screen share off. There we go. Okay, so going back to the book, so let's just go through the one. So the first one is the scatter plot. It is normal, like we just saw, so that would be there's a linear relationship. The residuals are normally distributed. That was the scatter plot did.
Mm-hmm.
The variance of the error term is constant to all variables. How do we figure that one out?
That was the
Oh.
one where you look at the pattern in the scatter plot of the residuals.
Oh, the scatter plot. Okay, so that's it. Okay, so the residual scatter plot is for the variance, and then to know if the residuals are normal, you go cube the plot of those two.
Yeah.
And then x's are measured without error? I think so.
I think
That's
it's
as long as they're normal numbers, right? Sorry, go ahead.
I don't remember the exact wording, but I think the wording seemed like it was suggesting that anyway.
Okay, so in the lesson it says the x's are fixed and measured without error. In other words, x's can be considered as known constants. Known constant. Not constant. It says x's can be measured accurately and precisely.
Can you see that?
But it can't be checked directly.
Oh, go ahead.
Down under the under the requirement, the 3.5 requirement summary is when it says they can't be checked directly, but they just measured accurately and precisely. So I have that they're all checked.
Mhm.
Oh wait.
I made
Okay, rereading the question.
a lot, so I don't know if you can see it, but here it is.
Hold on, let me. Yeah, that's what mine looked like. That's perfect. Yeah, that's exactly what mine looked like too.
Mm-hmm.
Woo-hoo!
So all checked. What is B1?
Okay, I just reread the question. The question 8 says, given the scatter plot, the residual plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? So they're just saying, what do those 3 tell you?
Oh, okay. So scatter.
So the scatter. Go ahead. Yeah, sorry, I'm talking a lot.
So we take off the bottom 2, right?
Yeah.
Let's see. So I got 12.725 for the slope.
Okay, sorry, I'm trying to pull it up really quick. Come on, little guy. How do you do the t-test for on the SPSS? Do you just go to like a normal t-test? Or did you do it in Excel?
Oh, I just did it in Excel.
Okay, I'll just do it in Excel then. That's perfectly fine. So that's okay, I'm back. Okay, so for the t-test for this one, I got 12.476. Oh, wait, I'm reading off the wrong answers. Let me back up a little bit. So for the slope,
I got 12.725.
You did?
Yeah.
Oh no, maybe I put in the wrong. Okay, let me try to copy it over one more time because maybe I copied it wrong or something.
You put the confidence as the X and the score as the Y.
No, I flipped them.
Oh,
So glad you said something. Let me see. That would have made all the difference. Okay, so confidence is X. Good thing you caught that the first time. Okay, so yeah, now I got 12.725.
and let's see. Confidence interval. I got 10.708 for lower bound. And 14.7742 for the upper bound.
14.742?
Yeah.
Me too. Woohoo! Okay, perfect. Based on the evidence using the significant of 0.05, what decision should be made regarding this hypothesis test? So, p-value.
P-value is less than 0.05.
It's very small, yeah. So we should reject it?
Reject the null hypothesis test because, I guess, because the p-value is less than alpha.
Yeah, perfect. I didn't know this because nice job. For the hypothesis test, if you reject the null, what does this mean? There's insufficient evidence to conclude that the slope of the regression line is not zero. There's insufficient evidence to conclude that it's not zero. Is that what? So I think it's the last one. What do you think, reading that over and over?
To conclude that the slope of the line is not zero, so there's sufficient evidence to conclude that slope of the line is not zero. There is insufficient evidence to conclude that the slope of the line is zero. So we know it's not zero. So
Well, isn't it? But I think the thing is that we rejected the null, or we. Oh. Yes, you're so right. I was thinking of the backwards answer. Okay, so it is not zero. So there is sufficient evidence to conclude that the slope of the regression line is not zero.
I think the way I think on the worksheet, the preparation assignment, the way they worded it was a little different.
Uh-huh.
It's kind of hard to tell, because from subject to subject, they kind of change the way and how you report it. No.
Yeah, that's true. That's
But
very true.
I kind of think it's the third one.
I think it's the third one too.
Okay.
That's what I was thinking, because it's pretty much just saying that there is sufficient evidence, which we know because we rejected it, to conclude that the null, they're like, P1 does not equal 0, which is our alternative.
Mm-hmm.
That sounds good. Okay, for the crocodiles, which was a dependent variable. Is there a difference between the two crocodile data? Are they both? So the head is X, right? So the dependent is body length.
I think we did it the same way both times. You know, we have the head length as the independent, body length as. Of course, I can't remember for sure, but I think that's the way we did last time.
I think it is. That makes the most sense. So the dependent variable is body. Okay, since the 99% confidence interval for these data is the interval is this, what do you say about B1? Since the confidence interval does not contain 0, there is sufficient evidence to conclude that B1 is not equal to 0. There is a 99% chance the confidence interval will contain the true value of P. I thought you were good chance.
Yeah, I don't
In a way, I kind of say but I'm not. It's not very, like theoretical, I guess. I mean, like.
yeah. I don't know. I kind of lean towards 2, kind of 1. I I don't think it's really like as far as 1 goes. I don't know if you can like determine a hypothesis test just by looking at the confidence interval. You know what I mean?
Yeah, yeah, that's my fear. A lot of sense, you know.
I mean, if it was that easy, why do we go through all this hypothesis testing? Why not just make a confidence interval and figure it out?
Yeah. But then I'm like, well, I don't want to do B because it says a 99% chance, and that
Yeah.
would kill it all.
We
Or you know what I mean? Just because it's a.
yeah.
But then there's evidence. But then the second one also just. Sorry, what were you gonna say? I feel like I'm always coming up.
Yeah, I was just gonna say that usually we haven't we stayed away from saying 99% chance. We've always said like we're 99% or 95% confident. You know.
Hold on. Yeah, I feel like I guess either way, I agree with you. I feel like 1 and 3 are kind of including a whole test.
Yeah. Well, I guess it's a 50-50 chance.
I don't know though. I kind of think. Yeah. I don't know. I think I'm gonna just go. I think I might just shoot for A because there's a 1% chance. You know, like even if alpha was 0.01, it's pretty unlikely that it's there.
Yeah, that's true.
I don't know. I don't know. Yeah, I'm kind of not sure. Well, hey, wait. Before we just pull our cards here, let me go over because we can look at notes, right, for this quiz. It says that at the beginning. I just always want to check. Okay, so. Hmm. Yeah, I kind of think it. I don't know. There's nothing really that. At the very end of the confidence interval talk, it does say, it just talks about reading them and making them. So it says one test had a confidence interval of -55 and -29.6. And they said if we put that in words, it would say we are 95% confident that an expected number of manatees that will be killed if there are no power boats is -5, 55, and -29. And they said that doesn't make sense. There can't be a negative number of manatees killed. So
Oh yeah.
in my head, I like to me, I'm like, well, maybe that goes with A. It's just kind of explaining what the confidence interval says. But if I think either way we're 50-50, like you said. So should we just guess for one and go?
Yeah. Let me take a little.
Which,
I guess look a little bit more. Okay. That changes by 1 minute. What's it called? Oh, that negative number is the confidence interval for the y-intercept.
sorry, say it again.
No, that negative number, the negative, has like the -55 to negative.
Oh,
That's for the y-intercept. The y-intercept that it estimates is 42, -42.542.
oh, okay.
So it's estimating that anyway. And yeah, it doesn't really make sense. So you just kind of, you graph it, use it to graph the line, but you just kind of ignore that point.
Yeah.
So in this
I don't know,
case,
what does your gut tell you, Cole?
oh, okay, slope. What would they say the confidence interval is for? For these data. What can you say about the slope? Oh, so that's for the slope. We are 95% confident. We are 95% confident that the number of manatees killed will increase between that. Or in other words, if 100 additional, 100,000 additional particles are registered reported, we expect 11.2 to 14.6 kill. Oh, okay. So, actually, A might be correct.
Really?
Yeah, because if you
What
look at
did
the
you?
end of the paragraph, it says we are 95% confident that the number of manatees will increase between this point 112 and point 146. Or in other words, if 100,000 additional power boards are registered in Florida, we expect 11.2 to 14.6 manatees will be killed.
Yeah. I think so. I think that's true. I mean, obviously what you read is true, but I agree. I think the best one's A.
Yeah.
Okay, I'm gonna submit it. Here we go. If I screw then don't. Just kidding. Yeah. That's awesome. We did it. Barely made it. Hey, my friend, she sent me the video about Rexburg. Now that I'm sure it's not like the coolest thing ever, but I thought you'd like it. I don't know. Anyway, I haven't even watched it all because she sent it while we were doing this, but It's just 20 seconds, but it said that MC flooded. So I don't know. You know how like there's friendship, privacy laws, and whatever. But if you can see that, I just sent it in Google Chat.
Okay.
Hopefully you enjoy it. But just from the first clip on the video that when you emailed it to me, it looked like.
So what was that? I just pulled it up real quick.
Oh, it just looked like it. Okay, I was like, that's what I did when she emailed it to me. You probably heard it get pulled.
It's another great day at BYUI.
That's funny. Yeah. What a perfect comment. That's awesome. Yeah, I haven't. It's just short. I haven't seen all of it, but I just saw that it was in the MC, and I thought, wow, that is some serious flood. It's crazy. So, okay, well then we'll see each other on Thursday, and it's a review for the test.
Yeah.
Okay, awesome. Thanks so much, Colby. I hope you have a great night.
You too. Bye.
Okay, see ya. Bye.